Hi everyone, so this is a lesson on in our circles topic, finding the perimeter of a semicircle. Now, when we find the perimeter of any shape, we need to add up all of the sides. So we're going to look at example 1 here, which is to find the perimeter of these semicircles in terms of pi. And as I just said, the perimeter of any shape is to add up the sides. So for a semicircle, we can see that we have this straight edge here, which I've just highlighted in green, and then we also have a curved edge, which I've highlighted in pink. Now we need to add the length of the straight edge and the length of the curved edge together to get the perimeter. So I might just start off by writing that the perimeter is going to be, and I'm just going to give myself some empty space. So the length of the straight edge, and I need to add that to the length of the curved edge. Okay, and that's going to be my perimeter. Now, the length of the straight edge is nice and simple. We can see the straight edge here is labelled as 4 centimetres, so I can write that in straight away. But the curved edge is not quite as simple, is it? Because it's part of a circle. In fact, it's half of a circle. And we learnt last lesson that to find the circumference, so the pink line, so the length around a circle, we use the formula pi d. Okay, and that gives you the line, the length of the line, all the way around a circle. We've got a semicircle though. So to get the pink length, I need to do pi d, a full circle, but I need to half it. So away from my perimeter calculation, I'm going to find the pink length. So I need to do, in fact I'm going to use my highlighter. So the length of the pink line is going to be, a little bit weird, isn't it? Is going to be pi d divided by 2. Okay, because pi d is a full circle and we've got half of a full circle. Pi d gives us the length of the line around a full circle and we've got half of that. So pi d is pi times the diameter, and I can see the diameter here all the way across is 4. So I've got 4 pi over 2, which is equal to 2 pi. Because 4 divided by 2 is 2. So the length of the pink line is 2 pi. And because I want to leave my answer in terms of pi, I'm actually finished, because 4 plus 2 pi, I can't collect the like terms there. There is no like term. So that's my full answer. So I might just at the bottom of my work put perimeter equals, I'm going to put the pi term first, so 2 pi plus 4, and this is all in centimetres. So that's my final answer. Okay, so quite simple, right? So we'll go on to the next one, and again we want to find the perimeter of the semicircle, which is the length around the edge of the semicircle. So I've got this straight edge here, which I need to find the length of, and I'm going to add it to the curved edge, and that will give me the perimeter. Okay, so the perimeter will be these two added together. I've made sure to put my pink one first this time. So the green edge is always slightly easier, the straight edge, isn't it? So I can see that I've been given the radius here from the centre to the outside of the circle, which is 10. So that means my green line will be 20. And now I need to find the pink line. So I'm going to go away from my perimeter work. I'm going to come over here, and I'm going to find the length of the pink line. So pi d is the equation that I'm going to use. Pi d is the length around a full circle, but I need to half that because I have a semicircle. So I'm going to substitute in what I know. So pi times d, pi times the diameter. The diameter is not 10 because 10 is the radius. The diameter is actually 20. So I'm going to have 20 pi, and then I half that. So I have 10 pi is the length of the pink line. I'm going to pop that in here. So my final answer for this question, I'm I'm going to pop this in brackets, 10 pi plus 20, and this was given in meters. Okay, hopefully that makes sense. I'm going to do 2 more examples. And this time we're going to be rounding our numbers to 3 significant figures, but the method is exactly the same. We want to find the perimeter of these semicircles, which is to add up all of the side lengths. So, just as I did before, I've got a straight side length, and I've got a curved side length, and they need to be added together to get my perimeter. So I'm going, oops, that's smushed a little bit. I'm going to find the length of the pink side length first. So I'll do that here. So the pink side length is going to be pi d for a full circle, but divided by 2. Now the diameter is 2.6 all the way across, so I need to do 2.6 pi divided by 2. And because this question is to be rounded to 3 significant figures, I'm just going to type this into my calculator. So maybe I'll put it here. So 2.6 pi all over 2 gives me 13 over 10 pi. And what I'm going to do is, what's tempting to do here, guys, is to put this decimal here and round it. But I'm not going to do that. We are not going to round this until the very, very end. Okay? So I'm just going to write 13 over 10 pi here. That is the length of the pink line. Okay? Now I'm ready to do my perimeter. Because remember, perimeter is going to be, well, it's the pink plus the green, isn't it? All my colours. So my pink plus my green. So my pink, I just found out, is 13 over 10 pi. And my green is 2.6. Now this is what I'm going to type into the calculator and round, okay? Because I haven't rounded this, it means I'm going to get the exact correct answer. So I've already got 13 over 10 pi in my calculator, so I'm just going to press add, and you can see that it goes and add. That means your previous answer, this, plus 2.6, and it's going to give me my answer 6.68. So to 3 significant figures, first significant figure, second significant figure, third significant figure, and there's a 4 next to it, so we keep it as it is, an 8. So 6.68 centimetres rounded to 3SF. We're going to put our rounded, putting what we've rounded it in there too as well. That's super professional to do that. So hopefully that makes sense. It's only a little bit of an extra step. So in our next question, same thing. We want to find the perimeter, which is going to be our straight edge added to our curved edge. Okay, so the perimeter is when we add these two together. You just add up all your side lengths. And semicircles only have 2 side lengths. They have 1 straight side length and 1 curved. So we want to find the length of the pink line. So I'm going to do that in a separate bit of space over here. And for a full circle, the length around a full circle is pi d. But because we're dealing with a half circle, we divide it by 2. So I'm going to substitute in the diameter. So I've been given the radius 19, so my diameter is going to be double that. So we need to have 2 times 18, which is 38. So we have 38 pi over 2. And 38 over 2 is 19. So we have 19 pi as our pink length, which I'm going to write straight into here. I'm not going to round it. Remember, I'm rounding at the very end. And then my green is 19 plus 19, which is 38. And this is where I type into my calculator. So P equals 19 pi plus 38. And to 3 significant figures, well, I've got my first significant figure, second significant figure, third significant figure with a 9 next to it. So that tells me to round it up to a 7. So I have 97.7, this is in millimetres, rounded to 3SF. Okay, I'm done. So hopefully you can see this is quite simple to do. We're going to do one more example. So example 3 is down here. Don't have as much space to work with. And I want to find the perimeter of this shape to 1dp. And remember, perimeter is just all of your lengths added together. So I'm going to highlight them. So I've got a curved length here. I've got that pink one. That's the same as in the semicircles. And then I've got a straight length here. And then I've got 2 shorter lengths here, which I'll do these in blue. So this shape has 4 sides. Okay, now some of these lengths I can just pop them straight into this equation. So for example, the green I can already see is 10 millimeters. And the blues I can already see are 4. It's the pink that's going to require a bit of an extra calculation. So I'm going to do that over here. Now it's a semicircle, so it's half of a full circle, and a full circle is pi d, so I need to do pi d over 2. Now the diameter, you might think, I'm not sure what the diameter is. The diameter is going to be all the way across the circle like that, isn't it? And on our diagram we can see that's going to be the same as that green length there, 10. So we're going to have 10 pi over 2, which is 5 pi. And I'm going to pop that into my perimeter equation, 5 pi. So I'm ready to type this all into the calculator now. The question doesn't want this in terms of pi. If it did, I would have 5 pi plus 10 plus 4 plus 4 plus 18. That would be my answer in terms of pi, but we want this to 1dp, so we're going to type into our calculator 5 pi plus 18, and to 1dp we have 33.7 millimeters. Give our rounding as well, and we are done.